Welcome to Module 8, Lesson 3, Solving Percent Problems. All right, so today we're going to talk about how to use those conversions that we've been doing and how to use them to find a part and a percent, or how to find, so basically what we're going to do, let me restate that. Basically what we're going to do is we're going to figure out how can we find one of the missing pieces. So those pieces are the whole, the part, and the percent. So when given 2, how do I find the third? And we're going to work with all those different combinations. All right, so first and foremost, we're going to go through modeling a percent problem. And so we're looking at a sports store received a shipment of 400 baseball gloves. 30% were left-handed, and we want to know how many left-handed gloves were in the shipment. All right, so this is for all you lefties out there. So we know that 30% means 30 out of 100, right? But in this case, we're talking about out of 400. So if we go through and we want to know how many left-handed gloves were in the shipment, it's important to note that there were 400 gloves and 30% were left-handed, okay? Excuse me. So we know that there were 30 left-handed gloves for every 100 gloves in the box. So if I model that over here, if I have a group of 100, this small group here of 30 would be left-handed. So again, here's another 100 total. And if I have another 100 total, I know that 30 of those 100 are going to be left-handed. So to continue my model, I know that right now this is 200, so I would draw 2 more boxes. Let's see where that went. There it is. Oh my goodness, where did it go? There it is. Sorry about that. So I have 2 more groups of 100. And in each of those 2 groups of 100, there are still another, so in that group of 100, there's 30 left-handed. And in this group of 100, there are 30 left-handed gloves. All right, so in our diagram, we can see that with each group of 100, okay, so in each large group, 30 of them are left-handed, and those are demonstrated by the small box within inside the larger box. So describe how the diagram models the shipment of gloves. So in each group of 100 gloves, there's a group of 30 that are left-handed. So that small group, and let me reword this, so in each group of 100 gloves, that small group, okay, so in each group of 100 gloves, there is a group of 30 left-handed gloves. And I can't click on this to type. So that shouldn't say that, it should say there is a group, or there are groups of 30 that are left-handed. Okay, so in each group of 100, there's a group of 30 that are left-handed. Right? And you can see that again in the model by showing that here's a group of 100, and then this small group here, that indicates the ones that are left-handed. So how can we use the diagram to find the total number of left-handed gloves in the shipment? Well, what I can do is I can take the 30 from each of these groups, and I can multiply it by the 4 groups that there are. Okay, so I can do 30 times the 4 groups and get that there are 120 left-handed gloves. Or I could have used the model and said 30 plus 30 plus 30 plus 30 gives me 120. So I could have added 30 the multiple times, or I could have multiplied 30 and 4. But either way, again, in each group of 100, 30 of them are left-handed. Since there's 4 groups of 100, there's 4 groups of 30 left-handed gloves, which means total there's 120 left-handed gloves. Another way to model this is to use a bar graph, okay? I shouldn't say a bar graph, it's just to use the bar. So in this case, I have 400, and I've split it into 10 groups, right? Because I know that it's 10 groups because each one of these is 10%, and I'm going from 0 to 100. Well, to do that and go by 10%, 100 divided by 10 gives me 10. That means I need to have 10 boxes. So in here, I can figure out that if I do 400 and divide it by 10, because I have to figure out how much are in each of these groups of 10, I know that I get 40. So that tells me that every 10% is equal to 40. So 20% would be 80, 30% would be 120, and 40% would be 160 because I continue to add 40 as I go. 50% would be 200, and then 60% would be 240, 70% would be 280, and 80% would be 320, and 90% would be 360, and of course 100% would be 400. Okay? So again, since we divided it into 10 equal parts, we can take 400, divide by 10, and figure out that each box is not only worth 10%, but that 10% is equal to 40 left-handed gloves. So every time you go up by 10%, you go up by 40 gloves. So how did we determine the labels along the bottom bar for Model D? So like I mentioned before, the bar had a total of 400 and it was divided into 10 groups. So when I did 400 divided by 10, that told me that each box had to be equal to 40. So then how can I use the bar model to find the total number of left-handed gloves? I can, since I'm looking for 30%, I can follow that down, and when I say follow it down, I mean like this. So I can find that there's 30%, and when I follow it down, because these numbers correspond together, so each of these numbers in here correspond with each other. So 30%, if I go down, I notice that that is equal to 120. And that tells me that then 120 of those gloves are going to be left-handed. Right? So we can use models to kind of help us out, and we'll be doing that a couple of times. But then we can also use just straight up math. All right, so we're going to talk about the first two problems. I'm going to set up proportions, and with the last one, we're going to set up an equation. Okay, so plain and simple here, we want to know what is 28% of 25. And it tells me that I want to use a proportion. Okay, so when I'm using that proportion, every single time I write a proportion, when it comes to percentages, it's always going to be my percent over 100 set equal to the part over the whole. Okay, so I can switch these, like I can do, and I'm going to use P and W for part and whole. So I can do part over whole is equal to the percent over 100 as long as I stay consistent. Okay, because the percent is always going to be our part, because 100 is always the whole that we need to make a group. So then when it's being compared to something else, 100 and the whole always have to go across from one another, because 100% represents a whole group. So in this case, to fill out my proportion, okay, I would put 28 over 100, because I know 28% is 28 over 100, is equal to X, which is the part, and I know I want 25 whole. So I want to know what is the part if I have a whole group of 25. If I have a whole group of 100, the part is 28, but now my group went down to 25, so what would that part be if I wanted it to stay proportional? Okay, so then here it says find the multiplication factor. What you're doing is the same thing that we've always done. We've always looked and said, okay, we have 28 over 100. Touchy board today. 28 over 100 is equal to something over 25. And I want to know, how do I go? So I can actually go the other way. I can say, okay, I'm going from 100 to 25, so I'm actually dividing. Okay, so here, how do I go from 100 to 25? So I'm going to divide, and I figure out that that is 4. So I did 100, and I divided it by 4 to get to 25. And then I know, okay, so I know that for me, or for this one, what I do to the bottom, I have to do to the top. So I'm going to divide each of them by 4. Again, it's still going to be 25. 28 divided by 4 in this case is 27. So what that tells me is 7 is 28% of 25. All right, and I'm sorry that 5 cut off a little bit. All right. But again, if you set up your pieces correctly, this is an easy problem for you to solve because we have done so well with proportions. So let's try this again. If you want to, what I'd like you to do is I would like you to pause it and try it by yourself and see if you get it right. If you feel like you need a little bit more, work through it with me. So write the percent as a fraction. So again, we want 35% of 60. So I have 35%, so that's 35 out of 100, is equal to what's the part out of 60. Right? So then now I have to figure out what did I divide by, because I went from 100 to 60, so I know that I have to divide. All right, so when I do that, so 35 over 100 equals what out of 60? So I do 100 and I divide it by 60. And when I do 100 divided by 60, I get, so let's go ahead and just remember that we have to put it in the right way, see what we get for our numbers, 100 divided by 60. And I get 1 and 6/10 repeating. So then again, that's what I multiplied by. So I know, or I'm sorry, that's what I divided by in this case. So then I'm going to do the same thing to 35. I'm going to take 35 and I'm going to divide it by, well, here's the hard part. How do I put in 1 and 6/10 repeating? My calculator does it, so I get an answer. However, for you, this might be a little bit more difficult, right? You might have to put it in and do some rounding, okay? But either way, we can say that 35% is equal to, so divide it by 1 and 6/10 repeating, and I get 21. So I know that 21 is 35% of 60. All right? So then now, another part that I want you to look at is 35%. 35% is less than 100%. So since 35% is less than 100%, the answer here should be less than our total. So it's 21 less than 60. Yes, it is. So does our answer make sense? Is it reasonable? I can say that my answer is reasonable because of the fact that this is less than 60. I can also look at it and think, okay, well, 35% is less than 50%. And I know 50% of 60 would be 30. So 21 should be less than 30. Is this true? Since it's true, I can say that yes, my answer is reasonable. Okay. Sometimes though, these numbers, so we noticed with that being our factor that we're working with here, sometimes it doesn't work out so nicely. Okay, so what we can do is we can set up an equation. All right, so I know that this might already be in your notes set up a little bit, so I'd like you to follow along with what we're doing. Okay, and make sure you're writing this in. So let's look for those keywords. I want 5% of 180. Okay, so if I want 5% of 180, of tells me I'm going to multiply. I know that I have to change this to a decimal before I can multiply. And 180 is already a number, so I don't have to mess with it. So I can change 5% to a decimal, and doing that gives me 0 and 0.5%. Now my problem is literally spelled out for me. So if I want 5% of 180. I know that I can change this to 5% as a decimal. Of means multiply 180. So look at this. This problem already gave us an expression just from the words. Then I can use my calculator to do my math. So I can pull my calculator back up and I can type it in. What is 5% times 180? When I do that, I get 9. So I know that 9 is 5% of 180. So again, you can do a proportion or you can do any, well, in this case, it's an expression. Other times it's going to be set up as an equation, all right? We are going to do a little activity where it helps you remember how to set up the problems. But again, if you can remember for your proportions that it's percent over 100 is equal to part over whole, you're doing great. For your equation, it's always going to be your percent times your whole, and that'll equal your part. I would make sure to have this written down in my notes somewhere. Both of them. All right, so in B, the percent is 35%. So what is the part and what is the whole for the other ratio? Well, in B, since 35%, so 35 is the part of 100. So in the other ratio, then 21 is the part and 60 is the whole. Because again, 100 is always your whole, and it's always your denominator. And the percent is always going to be equal to your part. Now for 4, what I want you to do is I want you to kind of write your own step-by-step plan of how you would use the proportion. So if you had to explain to somebody using steps how you would use a proportion to find 35% of 600. So the first thing you could say is set up, so do step by step, set up a proportion. Okay, and I also want you to make sure, remember, part over whole equals percent over 100. Okay, and then if you can, do the example off to the side. So actually solve the problem off to the side. If you can't do it off to the side because you ran out of space, I'd like you to at least have it on a separate sheet that we can add into your notes. All right, so here you have your U-Try problems. I want you to go ahead and try to answer these. I am going to solve 5 with a proportion, but then I'm going to use an expression for 6 and 7. So that would probably be your best bet, so you get practice as well. Because you have to be able to utilize both ways. And this one is the proportion. All right, so go ahead and pause, try those, and when you come back, we'll check your answers. All right, so in this case, you should have gotten 19, 81, and 45 respectively for your answers. Here you have 38 per 100, and we want to know what that is out of 50. I divided each by 2 to get my answer. Because to go from 100 to 50, I divide by 2. So then in this case, this was a kind of nice one, x equals 19. Here, 27% needed to be changed to a decimal. Of means multiply, and 300 is our total, or is our whole, so it can go at the end, and I get 81 when I use my calculator. Again, change your decimal or your percent to a decimal. Of means multiply, 75. When you multiply these, you get 45. Remember, yes, we will be able to use those calculators, but I have to see this process in order to know that you understand what you are doing. All right, so now we're doing a different situation. So in the last one, we used the percent and the whole to find the part. So now what we're going to do is we are going to use the percent and the part to find the whole. So we're looking for the whole in this case. So the school principal spent $2,000 to buy some new computer equipment. Of this money, $120 was used to buy some new keyboards. We want to know what percent of the money was spent on keyboards. All right, again, I'm going to solve using a proportion, and then we'll have another one that I will, actually, you know what, I think I'm going to do a proportion and an equation for this one, okay, just so we see both of them. So for the proportion, it's percent out of 100, but, oh, and I apologize, this is looking for the percent. This is not looking for the whole. I was one problem ahead. I apologize. So this is looking for the percent, not the whole. So in this case, it's going to be x over 100 is equal to, now I have to look at my other information. He spent $2,000 and 120 of it was used to buy keyboards. Okay, so the total in this case would be 2,000 because that is the total amount that he spent, so that's going to be our whole. And then part of that money was $120, and that was spent on keyboards. So now what I can do is I can look and say, okay, how did I go from 2,000, so 2,000 divided by 100 equals 20. So I know that to answer this, I have to divide by 20. To divide by 20. So in order to get this answer, I need to divide by 20. So I'm going to do 120 divided by 20. 12 divided by 2 is 6. Okay, and these zeros cancel each other out. All right, so then in this case, 6%, because this is 6 out of 100, is 6%. Okay, so 6 out of 100 is 6%. So that was how we solved using a proportion. And I'm going to move the rest of this out. Right. Now, I'm going to use an equation for this one. Okay, so in this case, remember, it's always percent times the whole equals our part. So let's fill in the pieces. I don't know the percent, so I'm going to put an x. Times, we said the whole in this case was the 2,000, is equal to the part, which is 120. All right, so I know that in order to find my answer, I want to get x by itself, so I'm going to divide both sides by 2,000. Because these two things will cancel out, and then I get x all by itself equals, if I do 120 divided by 2,000, again, I can grab the calculator, and let's double check that math. So 120 divided by 2,000, I get 0 and 600ths. But remember, this is a decimal, so as a percent, I got to move that decimal twice to the right. X equals 6%. Okay. Another way we can look at it, part divided by whole, so is always going to give us our percent as a decimal. It's always going to work that way. It's like a fraction. 120 out of 2,000. We've talked about this. I can do the division using a calculator, or I can simplify, but I can do the division and I'm going to get the 0 and 6/10%, which turns into, or 0 and 6/100, which is going to give me 6%. Okay, so part divided by whole will always give me my percent as a decimal, then I have to convert it back to a percent. All right, so number 8. We're going to write 57% as a ratio. Which part of the ratio represents the part and which represents the whole? Well, 57% as a ratio is 57 per 100. And like we said before, the numerator, in this case 57, represents the part, and 100 is the whole. Because 57% always means per 100, implying that 100 is the whole, and that 57 is the part of that we have. All right, so here we have the your turn. We have out of 25 students in Mrs. Green's class, 19 have a pet. So 19 have a pet out of 25, and we want to know what is the percent that have a pet. And let's just double check. This says have a pet, so I know that I can use 19 to set up my problem. What I'd like you to do is I'd like you to set it up as a proportion, and I'd like you to set it up as an expression or an equation. And when you come back, we'll check your answer. All right, so you should have gotten 76%. As a proportion, it would have been 19 over 25 is equal to something over 100. I know that I had to multiply by 4. And when I multiply 19 by 4, I get 76. Okay, so then in this case, x would have equaled 76. And since it's 76 out of 100, that gave us the 76%. You could have done this two ways. You could have said for the expression or the equation, you could have said that x times 25 gives you 19. Or you could have simply done 19 divided by 25. When you did that, either way, because that's what you end up doing, don't you end up dividing by 25, dividing by 25. So x equals 0 and 76/100, which again, this gives you 0 and 76/100. So we know as a percent, we move that decimal twice to the right, and we get 76%. All right, guys, hang in there. We've just got one more example together. And this one, we actually are finding the whole. This was the one I thought we were on before. We got one more example together where we're going to do the proportion and we're going to do the equation. You have 2 more you try problems, and you are on your own with this until we come back and do it in class, all right? So here we go. First, we're going to do a proportion. And an expression and equation. Whew. All right, so 12 of the students in the school choir like to sing solos. These 12 students make up 24% of the choir. How many students are in the choir? So I want to know how many students are in the choir. I know that this represents the whole, because if I'm talking about the choir, I'm talking about the whole group. Here, I know that 12 is the part because it's only some of the students in the class. And they make up 24% of the choir. And isn't that what we're looking for? The choir is made up of students, and we want to know how many students that is. So for my equation, I'm looking for 24% of the choir, which I don't know, so that's x, and that's going to be 12 people, because because I know 24% of the choir is equal to 12. So what I can do is I can say 24% of the choir is equal to 12. So I can say 24% is 24 hundredths. Of means multiply. The choir, we don't know, so let's use C, change it up a little bit, and I know that when I do that, I'm going to get 12. Again, I would divide both sides by 24 hundredths because I want to get C by itself, and I want to undo the multiplication. These cancel each other out, and I get C is equal to, oh goodness, I can't draw my line here. Sorry about that. C is equal to 50. And I know that seems weird, but when you divide by a decimal, you are going to get a larger number. All right, so let's double check my math. Because, you know, we're human, we make mistakes. 0 and 24 hundredths. Hey, look at that, I didn't make a mistake this time though. So I know that C is equal to 50, 50 being the number of students in the choir. Okay, so here's my equation. As an expression, I can tell you that your whole is always going to be equal to your part divided by your percent, but your percent as a decimal. So let's test my theory out. We don't know the whole, we don't know how many kids are in the choir, but we know that the part 12 divided by the percent will give us our answer. Isn't that exactly what I did right here? And when I did, same thing. I'm still doing 12 divided by 24 hundredths, and I still get 50. Let's go back to the proportion, as I'm sure you're all begging me to because you know you like it better because it's always easier. Okay, we have 24%, so that's out of 100, is equal to, my part is 12, my whole I don't know. And again, I'm going to use C because it's choir and I want to change it up. I know to go from 24 to 12, I divide it by 2 to go that way. So what I do to the bottom, I have to, in this case, what I did to the top, I have to do to the bottom. So I'm going to do 100 and divide it by 2, and I get 50. So C is equal to 50. So there are 50 students in the choir. Again, do I expect you guys to have this down pat when you come to class? No. Do I expect you to have tried it and to come in with what you think was the correct way of doing this? Absolutely, all right? We do have a couple of days on this, so don't stress if you're having some trouble. If we're talking about reasonableness of our answer, so in example 3, 24% equals 12, all right? And I want to check the reasonableness of my answer, so I want to know, I look at 24%, and 24% is close to 25, okay? So 24% is close to 25. 25% then, I apologize, and I know that 24% of this, and it gave me 50. So this was all of my work. This is what I got. I know that 24% is close to 25%. All right. So 25% of 50. So if I check that out, 25% of 50 is 12 and a half. So does it seem reasonable? So if 25% of 50 is 12 and a half, does 50 being the whole seem reasonable for 24% being equal to 12? So it's kind of a backwards way of thinking about it. So 25% is equal to 12 and a half. So 25% of 50 is equal to 12 and a half. 50 makes sense as our answer when 24% is equal to 12. Again, this is going to take some getting used to. We'll talk about it. Right now, my focus is setup, work, and then answer. in that order. One priority is getting it set up. Second priority is can you do the work correctly? The third priority is then getting it to the correct answer. Because if you can do 1 and 2, 3 is a breeze. All right, so again, this one I want you to use the proportion, and this one I want you to use the expression in equation. When you come back, we'll check your answers. So here, 6% of 30 should be 20. Or I'm sorry, 6 is 30% of 20, and 15% of 500 is 75. So let's take a look at this. So 6 is 30% of what? So to remember that, so 30%, if you weren't sure where it goes, you know 30 is out of 100, right? And then we want to know 6 is 30%. Well, if 6 is equal to 30%, we know that it has to be the part because we said the percent is always the part. So 6 has to go on top. X goes on bottom. Okay, to go from 30 to 6, I divide it by 5. So to go from 100 to X, I have to divide by 5, and I get that X is equal to 20. Since this is not a percent, we don't have to, like X that we're looking for is not a percent, so we don't have to move our decimal. Here, so with the equation, so 15% of something equals, so is our equals, right, 75. Okay, so 15% I know has to be changed to a decimal. Of tells us to multiply. When we don't know the number, we use a variable, and 75 is what it is. And I know is always going to be my equal sign. I end up dividing both sides by the 1500ths. Okay, these cancel each other out, and X is equal to whatever the answer is, which in this case gave us 20. Now, since I know that we might not necessarily have covered equations yet, I know that this is a little confusing. Some of us may be ready for it though. So if you're having some confusion on this, I want you to make sure that you focus on the expression and the proportion, okay? We will get plenty of practice with equations. With the expression, we said that it's always the part divided by the percent as a decimal. So it's going to be 75 divided by 0 and 1500ths. Wait, why did I say 20 here? This is 500. My goodness, you are probably thinking I'm crazy. Sorry about that. So then 75 divided by 1500ths gives me 500. And we are there, ladies and gentlemen. We are done with this lesson. You have the guided practice. Again, this guided practice I'm not doing online because there's so many, look at these different pieces that you have to fill in. We'll go over it when you come back to class. Make sure to have it done, please, all right? I always ask you just to try and do your best so that way we can go over it as review. As always, if you have any questions, please be sure to email me or write them down so we can go over them in class.